when I'm dealing with absolute value inequalities, the first thing, we always have to have the absolute value bars by themselves, isolated on one side of the inequality, and then everything else on the other side. Okay. Once once that happens, then I need to figure out if this is an and statement or an or statement. Say that 10 times. Okay. In this case, I have a less than sign, right? And this goes true for less than signs, less than or equal to signs. If I have, when I have this isolated, the absolute values, and I have a less than or equal to sign, I have an and statement. Unlike greater than or equal to signs, greater than or greater than or equal to, I have or statements. Once I have that figured out, once I have that set up and everything, from that point on, it's all 1.5 part two. So I'll review from the previous two sections ago, right? Once I have this set up, it just becomes a regular compound inequality problem, 1.5 part two. So the only new thing is taking it from absolute value to the setup step. Once it's set up, this should be all review. Now, the example problems, they did that for us. They actually did the new stuff for us. So let's go ahead and solve these inequalities. It'd be good review from 1.5 part 2. So I'm going to have to get x by itself for both of these inequalities, right? So on this one, I'm going to subtract 7 from both sides. I get 2x. The sign stays the same because I'm subtracting, so I'm not even multiplying or dividing. 11 minus 7 is 4. Divide both sides by that coefficient 2. And I get x is, I'm dividing by a positive number, so the sign stays the same, is less than 4 divided by 2 is 2. Bring down my little conjunction word here, and then I solve the other inequality. So I'm going to subtract 7 from both sides. And I get 2x. I'm subtracting, keep the sign. Negative 11 minus 7 is negative 18. Then divide by that coefficient 2. And I end up with x is, even though this is a negative number, I'm still dividing by a positive number, so the sign stays the same. It's only when I'm dividing or multiplying by a negative number that I have to switch it. Negative 18 divided by 2 is negative 9. Then I'm going to go graph this. Let's say I want the smaller number, be careful here, is negative 9. The larger numbers, my 2 This is an and statement. Okay, so that means it's a sandwich in between sandwich thing. There are no equal signs for this inequality, so this gets a parenthesis, and no equal sign for this inequality, so this is also a parenthesis. Interval notation, parenthesis, -9, comma, 2, parenthesis. Again, everything from here down is 1.5 part 2. Questions? Or you can ask the lady with the big pencil if you have any questions too. Um, all right, or problem. Again, they went ahead and set this up for us, so we don't even get to use our new stuff yet. So let's go ahead and solve this. I'm going to add 2 to both sides. So I get 3x is greater than or equal to 10. Going to divide by 3. So this solution is going to be x is greater than or equal to, because I'm dividing by a positive, 10 thirds. Bring down my or and solve this inequality. Add 2 to both sides. So I get 3x is less than or equal to -8 plus 2 is -6. Divide by the coefficient 3. And I get x. And again, even though that's a negative number, I'm dividing by a positive, so my sign stays the same. -6 divided by 3, -2. Graph it. Put my smaller number on the left side, which is -2. Negative's always smaller than a positive. Here's my 10 thirds. It's an or statement, so it's that both ors, right? This goes out to positive infinity. This goes out to negative infinity. Let's see. -2 has an equal sign. So this gets a bracket. Let's see, our 10 thirds is also an equal sign. Gets a bracket. Interval notation, left to right, negative infinity, comma, -2. This always gets parentheses. My -2 is the bracket. Union, bracket, 10 thirds, comma, positive infinity, parentheses. So we did these 2 example problems, and we didn't even use the new concept yet because they did it for us. This was all reviewed. So starting with problem number 1, we actually have to use our new concept that we must learn. And that is when I have absolute value bars isolated by itself, I look at the inequality sign. This is a greater than inequality sign. So what word am I going to use? And or. Greater sign. What do I use?
Or.
Or. Okay. So let's set it up. I have 4x plus 10. Now I'm going to use, I like my negatives on the left hand side and my positives on the right hand side. So I'm going to put my -2 over here. Okay. But again, I'm going from a +2 to a -2. I have to do what to the sign? Flip it because I'm multiplying that by -1. We already said it's an or. And then I'm going to take my 4x plus 10. I'm going to keep the +2, which means I'm going to keep the sign. Now, I'm just going to use 1.5 part 2 and finish this. So go ahead and solve each one of these inequalities. So I'm going to subtract 10. I know these are long and whatnot. So I got 4x less than -2 minus 10 is -12. Divide by the coefficient 4. And my solution for this one is going to be x. And -12 divided by 4 is 3. Dividing by a positive number, even though that's negative, I'm dividing by a positive, so I keep the sign. Bring down my or statement and solve the other inequality. Go through that whole thing again. Subtract 10, subtract 10. I have 4x greater than 2 minus 10 is -8. Divide by 4. Divide by 4. I have x. Um, -8 divided by 4 is -2. It's a +4, so I keep the sign as is. This should be a -3, right? Let's see. -12 divided by 4 is -3. Yep. Okay, smaller number, -3. Larger number, -2. It's an or statement, so the both ors going out to infinity and negative infinity. My interval notation, negative infinity to -3. Oh, it's parentheses, right? There's no equal sign here or there. So that's parenthesis. Union, parenthesis, -2. And infinity always gets parentheses. So that one we did from the very beginning to the very end. Any questions on that? Numbers 2 and 3 have those asterisks, so there's something going on with them, right? So let's look at number 2. I have my absolute value bars isolated on one side of the inequality, so I don't have to worry about moving or undoing operations. I am going to take a look at this problem before I start doing any work. See if I can save myself some time here. What kind of number am I going to have? First of all, absolute value bars means what again? Distance, right? And what does distance have to be? Positive number, right? Andrew, right? Sorry. So that's a positive number. Okay. Um, this is a negative number, right? And and it's saying that this positive number is always going to be greater than or equal to -4. Well, wouldn't that be true for no matter what I pick for x? Even if I pick -10,000, well, -10,000 times 2 is -20,000 plus 3. It's going to be -20,003, but the absolute value bars is going to make that positive. So it's 20,003. In fact, no matter what I pick for x, I'm going to get that positive number, right? So what numbers are going to work in this for x? I just gave you the answer, right? No matter what number I pick for x, it's always going to come out positive. So what can x be? Anything, right? It could be any number. The solution is all real numbers. Okay? The symbol for all real numbers is that double bar R. So you could just use that. If you wanted to graph it, if they told you you had to graph the solution, well, you just shade the whole thing with arrows. There's the graph. And then they said, well, you must put an interval notation for all real numbers. Well, it's going from negative infinity to positive infinity, and they always get parentheses. Yeah, Justin.
How can you tell when it's in the all number situation?
Well, I get a feeling 3 is going to be the opposite. So let's take a look at these two for the difference between these two problems. Okay, so hang on a minute, then we'll sum it up. Okay, so let's look at number 3. We know this one's all real numbers because we get a positive number that was, and all positive numbers are greater than negative numbers. Let's take a look at number 3. Well, the first thing I have to do is isolate the absolute value bars, right? So I have to undo a +8. So I'm going to go ahead and subtract that +8, right, to both sides. Now what do I get? Well, I get the absolute value of 4x minus 9 is less than or equal to 5 minus 8. Gives me -3. Remember what I said about what we said about absolute value symbols, right? Anything coming out of absolute value symbols is what? Positive number, right? So this time, we're going to get a positive number just like up here. This time, they want it to be less than a negative number. Is there an instance where any positive number is less than a negative number? Can that happen? Can it happen? Yeah, we get it. There's nothing I can plug in for x that'll make this positive number less than a negative number. So there's your answer, right? If we have an absolute value less than a negative number, there's no solution. If I have an absolute value greater than a negative number, it's going to be all real numbers. You guys want me to do number four? You had enough of me. You guys are either really on holiday mode or I think you had enough of me. I think I'm going to end it here. Give you your homework. Any questions, guys? None?